So my name is Connor Horn. I am an intern in the SULI program, which is the Science Undergraduate Laboratory Internship Program. And I go to Cornell University and I work in the Materials, Physics, and Engineering group in Sector 1 of the Advanced Photon Source. Argonne's really been a cool and unique experience for me these last 2 summers because I've gotten to see how working down at the beamline really works with the scientific community and the impact that it has. And I really can see myself inserting into the scientific community here and hoping to make breakthroughs in the future through what I've learned from this internship. So it's important to know information about stresses and strains within materials because we will test them under load and under extreme circumstances, and we want to know how they respond to these circumstances. The individual grains within the materials will all respond differently depending on different orientations that they may have. So the X-ray methods and techniques that we use at our beamline will take advantage of the photons that comes from these X-rays and how they interact with materials when we scan them. So they will hit a detector in a certain pattern, which we call a diffraction pattern, and we can use mathematical methods and codes that we have to get data sets about these, whether it be charts or line plots. And from these, we can get information about stresses and strains within materials and learn more about them, their properties. The wheel that I worked on this summer will have impacts for the scientific community, but also the general community as a whole. So an example of this would be the shape memory alloys that we scanned with these wheels this summer. We scanned over 200 of them, which were formed in different ways and using different techniques. So if you click on the folder that contains all the images, you'll see rows and rows and rows of all these images, and I said there are 80 for each sample. And if you click on one of these particular images, you will see a diffraction picture that looks like this. And you'll see the rings around here. You have to have the high intensity values as differentiated as possible from the low intensity values so that you can analyze it as well as possible. So the experiment that involved liquid nitrogen was a test of what we call shape memory alloys. They are metals that respond differently under different temperature conditions. They'll take on different phases. So what we were looking at was how they responded in such cold temperatures, such as liquid nitrogen, as compared to room temperature or extreme heat. So what these memory alloys are actually for, one example would be these stents that go in arteries and expand your artery, which would help with blood flow in patients that have a lot of cholesterol buildup or heart problems. Knowing more about these materials and the fact that we can scan so many different types of them so quickly allows the medical community to make the best stents for their patients and so they can receive treatment quickly. Some challenges I face, a lot of big challenges were the code that scientists use here is existing and typically specific to different projects that scientists will want to do. And I had to integrate that code into my new project that I was working on. So I had to first learn all the code that they use and its functions and then integrate it for what I was trying to do, which was at times difficult and involved a lot of troubleshooting, which is frustrating, but I eventually was able to figure it out. So. A word of advice that I have for students that are looking at Argonne for a potential internship would be to take as many science classes as you can and immerse yourself in science, whether that means be in contact with researchers at your school or in your community, whatever. I'd say that Argonne has such a wide variety of science that gets done here that it's a great place for me at least, because I was able to find so much of what I want to do in the future, and that's been quite a great experience. I was lucky enough to find an internship in the field that I was looking to go into in engineering physics. So it was good to get an idea of kind of where the field is at now and where it's going in the future. So I'm really still interested in materials and we'll probably do something related to the study of materials in the future, whether that be the same high strength materials that I'm looking here or something else, I don't know. But it's been really good to get an idea of kind of where the field is at and what scientists are really looking at these days.